السلام عليكم ورحمة الله وبركاته. الحين بنشرح يعني أنا قاعد أراجع نكون واقعيين، يعني ما أنا قاعد أشرح لأحد. 4.2 The Mean Value Theorem. simple lesson صراحة، وإن شاء الله ما يكون في أي مشاكل ويعني نعديه على خير عشان المترم يكون سهالات بإذن الله. So first things first, what is the mean value theorem and what theorems relate to it? So first we have a thing that is called Rolle's theorem. So what is Rolle's theorem? Rolle's, I don't know. Let f be a function that satisfies the following three hypotheses. يعني عندنا three شروط, three requirements. If it fills these three requirements, it satisfies this theory. The function is continuous on the closed interval a to b. If is differentiable on the open interval a to b. And 3, f of a equals f of b, which basically, I think it's pretty obvious what it means. So if f of a basically means that it's a straight line, but we can, or not a straight line, but you're gonna understand it now, hopefully. So then there is a number c in ab such that the derivative of f of c is 0. So basically the slope is 0. So we have four functions here. The first one is pretty obvious that it has the slope 0, and if we take f of a, it's gonna give us the same value as f of b. The second one, which is b, we can see that at one point the function stops increasing. So if the function has been increasing from a to until c, it just stops at one point where the slope would be equal to 0, and we know that the slope is basically the derivative of a function. I think you're gonna start to get what we're working on, what we want to do, what we can equalize. So I'm gonna jump the gun a bit and tell you what the mean value theorem would be. So the mean value theorem would be the derivative, which is the slope that we found, equalized with how we find the slope, which is y minus y2 minus y1 over x2 minus x1, which is basically what we're gonna do with the mean value theorem. So here at C, we notice that at C1 there is a maximum, and at C2 there is a minimum between B and C1. So at these points, at this very point, the derivative would be 0, or the slope is 0. So the slope equals the derivative. Okay, I'm having a stroke. Every video I have to have a stroke at least once or twice, just to make sure that we're going strong. Okay, so as we said, the slope is basically 0 at this point. Even here the slope is 0. So what is the mean value theorem? So these all satisfy Rolle's theorem. So now we can check. Let's try this. So we have this equation. We can prove it. I don't think we can prove this one. I'm not sure. This is very important. We can now jump to the mean value theorem, or the meat of this lesson, the main topic of this lesson. So first, we have some things that we want to satisfy. That it is continuous and differentiable. So it's basically the same rules as Rolle's theorem. Now we will get a rule. I don't recommend you just remember this one, since it's more straightforward and understandable, since it's just basically the slope formula. So the difference, the derivative of f of c equals basically the slope of the function from f of b minus f of a over b minus a. This is pretty simple and you can understand it hopefully easily. So like you can see here, you can see that the slope here would be the same slope as the one over here. So this is why we can make it, we can have the equal sign between them. So this is the slope of the secant line, which is basically secant line is this red thingy. It touches at just one particular point, المماس بالعربي. now or لحظة المماس كعلق مخي. I mean the secant line is this one. This is the secant, just explain. This is the secant line. This is the blue one is the secant line. The red one is the tangent line. So secant basically القاطع بالعربي. Now we have the mean value theorem. So to illustrate it, let's solve a example. So we were given A and B and the I don't think we need to use a separate note, so we can just do the f of x. It is gonna be 3x minus 1. Now what we do with this value? So as we know, we don't. So we can see here, they use the other formula, but I don't think we need to do so. So we would just find the derivative. Okay, we have the same derivative as they do, which is 3x squared. I mean, squared minus 1. Now, once we have this value, as you can see, we can equalize 3x minus 1 with okay, so I've kinda I didn't do anything wrong, but basically what we want to do is basically input these into the function so we can find the values that we're gonna use for the other side of the function. So let's use a calculator. 0 minus 0 is 0, so this one would be 0, and or I mean f of 0 equals 0, or let's say f of a equals 0, and f of b equals 2 cubed minus 2, which is 6. Now we have these two values. We can just put them into the equation that we have. 3x squared minus 1 equals 6 minus 0 over 2 minus 0, which is gonna give us 3. So we can say 3x squared minus 1 equals 3. Then we can add 1, so 3x squared equals 4. Now we can divide by 3. Then we're gonna get x equals 4 over 3. Then we find the square root, so it is gonna be 2 over square root of 3. So we have this value. Now it's minus negative, I forgot because of the 4. Now this value that we got is basically C. So if we look here, so at the value C that we got, this is the tangent line at this value. So we can see that it is parallel to OB. Hopefully, it can be a bit confusing at first, but hopefully once you do a few more exercises, it will be much easier. Now let's see what the example 5 has in store for us. We have f of 0 and we have, okay, how large can f, okay, so we know that it is differentiable, so it can be so it is continuous everywhere. So I'm gonna skip example 5 or should I, I'm not gonna skip it.